Good morning, good afternoon, good evening. This is Dr. Garais, and this is BIO112. This is a quick review of Chapter 12. Let's not do it this way. Let's do it this way. Okay. So, we're talking about sensory functions. You have two types of senses, general versus special. What's the general, of course, is I want you to think of joints and things that are skin and joints. Those are things that are throughout the body and they have general senses. The special senses are anything that are, in your head: eyes, ears, nose, and mouth. We already talked about receptors for several chapters, that they respond to specific stimuli, and the stimuli is just simply outward external energy that gets transduced or changed. For example, when you see things, your eyes don't really see things. Your eyes pick up light energy in the visible spectrum. If you guys remember Roy G. Biv: red, orange, yellow, blue, indigo, violet. Ultraviolet and infrared you can't see with your eyes, and they just get changed into action potentials for which the electricity the brain can understand. And then it is your brain, specifically for vision, the occipital lobe, that then interprets what you're seeing. Receptor types, you should know these: chemoreceptors, smell and taste. Smell is olfactory, taste is gustatory. And there are receptors all throughout your body that look at certain chemicals, like your aortic body is for oxygen concentration. There are chemoreceptors in your central nervous system, specifically related to your cerebrospinal fluid, that monitor carbon dioxide. Pain receptors are nociceptors. Thermoreceptors respond to changes in temperature. And if mechanoreceptors, I want you to think blood pressure and Golgi tendons, which is stretch receptors. And we talked about those in class. And stretch receptors, the Golgi tendons, are also regarding proprioception, on body movements, and also reflexes. Photoreceptors, we talked about that: rods and cones. Rods for night vision, cones for day vision, or day vision / color vision. Those are photoreceptors. Know the difference between sensation and perception. Sensation, remember, it's either the sensory is either on or off. Perception is the interpretation, or what the brain interprets the pain as. For example, the sensation, on or off. You're either itchy or not itchy. It's either itchy or painful, and then you feel that. But the perception is, oh, maybe it's just my hair bothering my back of my neck, and it is the interpretation. So perception, I want you to think interpretation. Sensation is either 0 or 1. It's either on or off. Now, projection, we're going to talk about how the interpretation of sensation can now be projected onto other sensations. All right, and we're going to talk more about that when we talk about referred pain. Adaptation, that's the seat example. The second I mentioned the seat, then you realize that you're sitting down and the seat is uncomfortable. But after a while, you don't feel it anymore. We gave examples of thermoreceptors and olfactory. You might be chilly or a little bit warm when you enter a room, but then you get used to it. Olfactory receptors, once you start smelling something, whether good or bad, you start not noticing it anymore. Okay, I gave the example of, a teenage boy's room, right? Stinks, but they hang out in there long enough, you don't smell it, or don't smell it as much. And that's sensory adaptation. Extroceptive senses, I want you to think everything that's on the skin: touch, pressure, temperature, and pain. Introceptive, I want you to think AKA, or also known as, visceroceptive. Visceral, think your visceral organs. You have no control over them, and you don't even know what is going on, but your body does, and your brain does. So a classic example is blood pressure. Proprioceptive, remember we talked about tendons and position sense, and pre-stretch, stimulated when changing the position or exercising, right? Proprioception is how, even when your eyes are closed, how you know where you are in the space of the world. If you're upside down, right side up, that kind of thing. Free nerve endings, simplest receptors, usually on closer to the epidermis, on the top parts of the dermis. They're for itching, but we already know misers and Pacinian. That's for light touch and deep sensation or deep touch. Warm and cold. Remember, if something in the thermoreceptors goes through the extremes, whether too hot or too cold, then it activates pain receptors, also known as nociceptors. And pain is a good thing. Pain tells you where exactly the problem is, or within the dermatome region of where the problem is. And you'll be learning a lot about that when you take your classes regarding the subjective history of your patient. Oh, forgot to mention, pain. The good thing about pain is that it doesn't adapt, right? And we'll talk about how you get used to pain, and there are things that make your pain go away, but they don't adapt like you would on the sensations of you feeling your chair, or your olfactory adaptation of sensory. Visceral pain, referred pain. We talked about the classic flank pain of your kidneys are located retroperitoneally, and they're located in your back. But when you feel flank pain, it's on your sides or near your loin area or your anterior lumbar area. Another example of referred pain is how chest pain or angina or chest pain in heart attacks radiate to the left jaw and to the left arm. And again, common nerve pathways. We saw that as dermatomes. We're going to see that in a minute. Tome or tope is tome means that you cut. You're cutting your body into certain dermat skin areas. And here's a classic example, and you can see here how your left chest can radiate to your left arm, and how if you see here, no, they didn't show it here, but your kidney regarding flank pain, it's the pain is really originating here, but you feel the sensation here in the anterior. Now, regulation of pain. Of course, thalamus is the gateway of sensation, so it's the beginning. Cerebral cortex, of course, you do the judgment. Gray matter in the brainstem, the ascending fibers for sensory. Now, pain inhibiting substances. We talked a little bit about this. There are three. It looks like a beautiful all of the above question. Enkephalins, serotonin, and endorphins. And we already know that serotonin, and these are three neurotransmitters that actually block the pain. Now, the signal for the pain is still there, but when it gets really bad, enkephalins, serotonins, and endorphins kick in to kind of modify it a little bit so you can tolerate the pain. Proprioception, we talked about mechanoreceptors in your Golgi tendons. That's this thing right here, right? The stretch receptors that give you position sense. Visceral senses, of course, internal organs. You may feel them, but much of the visceral senses is usually feedback for your autonomic nervous system. Special senses, smell, taste, hearing, And remember, cranial nerve 8, hearing and equilibrium go together. Olfactory, of course, nose, smelling, and the process of olfaction, the sense of smell, requires the chemoreceptors, which are hair cells, to be in an aqueous solution. So it has to be a little bit moist. You can't smell when things are super dry. And if any of you have ever been to a very dense jungle, it really smells in there because it's very, very, it's got a lot of fluid in the air that you can smell. And here are your hair cells. They're located here. And these are your nasal concha or shelves, right? And that's why if there's too much mucus, it blocks all of these and then you can't smell anything. You get congested. But you can see the hair cells. And you can see also why people snort drugs. Because it goes right here through the cribriform plate right into the brain. Okay, so that's olfactory, cranial nerve 1. And it is actually, these hair cells are actually chemoreceptors. And olfactory, you could see it's also related to the limbic system, right? And we talked about how emotional I can get at buffet. Taste buds are your gustation or gustatory sense is your sense of taste. And your taste buds are also comprised of hair cells. And different hair cells in different locations of your tongue because are chemoreceptors. And of course, they too have to be in aqueous environment. That's why when we eat, we just don't eat, we also drink water, hopefully. If you look at the taste buds here, sweet is at the tip, salty goes around this area here, so sweet and salty run together. Sour, you could see here, is a very different anatomy here, different morphology. And bitter is in the back. And in the middle is called umami, and that's called the savory taste sense. It's kind of like the culmination of all the taste senses all together. You don't need to know this. The locations are a little bit more common to learn in anatomy. But of course, salty is of course sodium. Sour, if you remember, like lemons, they're acidic. Let's go through the ear. Now there's a whole bunch of words, but I'd rather go through the story of your ear. Your ear is divided into 3 sections. You have the external, you have your middle, and of course your inner ear, where all the really important things are. Your auricle, also known as your pinna, which is your earlobe, it is for pretty sake, for aesthetics, and no real auditory function. But your external acoustic meatus, which is here through the middle ear, covered by cerumen, earwax, and some hair, its function is to funnel the sound down into the end of the middle ear, which is the border right here, which is your tympanic membrane, or your eardrum. The eardrum vibrates and then vibrates the 3 ossicles, your malleus, incus, and stapes. They call it the malleus because it looks like a hammer. The incus, it looks like an anvil, and the stapes here, it looks like a stirrup. You know, for I guess whoever thought looked at the ossicles, I guess liked horses. Who knows? But the ossicles are the smallest, most delicate bones in your body. They vibrate when your tympanic membrane is exposed to sound waves. The sound waves causes the tympanic membrane to vibrate, the malleus, incus, and stapes vibrate, and then that vibration goes through here, this section right here, if you can see my cursor, through this thing called the oval window. Then the oval window vibrates fluid that's inside this thing that looks like a shell, and that's your cochlea. Looks like a conch shell, doesn't it? And what do you do with a conch shell? You put it to your ear and you hear the ocean. So therefore, remember that through the ossicles, if I can get my cursor back, through the ossicles, vibrate oval window, there's this stuff called endolymph, There's fluid inside there that will move around hair cells, again with the hair cells in special senses, and then based on that, it then sends a signal to cranial nerve 8, your vestibulocochlear nerve, for hearing. Now, your vestibulocochlear nerve, cranial nerve 8, has two functions. This part here that connects to the cochlea is for hearing. This part here, the semicircular canals, which also has fluid in it, helps us with position sense as well and balance. And that also, those signals also go through the vestibulocochlear nerve. And that's why if you have an inner ear infection, you're not only going to have signs and symptoms of hearing loss, you're going to have signs and symptoms of dizziness, right? And they're together in the cranial nerve 8, which is sensory. Now, if you go diving or you jump in airplanes, jump into an airplane, not out of, well, also out of, your ears pop as well. There's a connection here from your nasopharynx, your nose slash throat, that part of your nose and throat, and there's this thing called your auditory tube, also known as your eustachian tube or eustachian tube, potato. It equalizes the inner ear pressures with your nasopharynx or your throat. There, so it equalizes the pressure. That's why your ears pop when you go really high in an airplane or an elevator, or when you go diving, deeper than 10-15 feet. Okay, eustachian tube, and the rest of this is words, and here is the picture of your semicircular canals with what the canals look like with the hair cells inside. And again, the fluid moves around, moves the hair cells, and then from there it tells you where's your head. Is it bent forward, bent backward, so on and so forth. Cochlea. Now, remember we talked about there's certain gateways or there's certain filters for your sensory. And the thalamus was what? The gateway, the first. Well, another filter is your medulla oblongata. Okay? But eventually, all the auditory pathways will enter the auditory cortex in the temporal lobe. So think hearing, think temporal lobe. Equilibrium, again, you have two types, static and dynamic. When you have stasis, you're not moving around, right? But it goes when you're moving around, that's really when your semicircular canals get into play regarding your balance. Okay, it's a better, clearer picture of your cochlea and your semicircular canals. Now, there's these little grains of, and they look like boulders here, or a bunch of tablets, but there's little grains called otoliths, and that's what rubs against the hair cells inside the semicircular canals, and that's what tells you where the position sense is. Same thing, hair cells, right? Fluid moves around, right? Moves this cupula, and then from that movement, you could tell how your head and how your body, how your head is moving. The eyes, well, you have your eyelids, they're called palpebrae, and I mentioned in class how your eyes are kind of sunken in your orbits of your skull. Your zygomatic bone and your skull kind of protect it. Another thing that your palpebrae or your eyelids do is also protect it from foreign body. Here's some parts of the eye you should know. Definitely know the outer hard covering of the eye called your cornea. This is the anterior chamber filled with aqueous humor. The opening here is your pupil, and here is your lens connected to your ciliary body, connected to your ciliary muscles. And your posterior chamber, which is full of jelly or gel, and that's your vitreous humor. So you have water-like material here in your anterior chamber, that's called your aqueous humor. Anterior chamber, aqueous humor. Posterior chamber, vitreous humor. Now, light bends through all these substances, and that bending is called refraction. And The function of your eye is to bend all of that light to the back part of your eye, which is the retina, which we're going to see in a moment, right? And your ciliary body and your ciliary muscles move around that lens so we can bend it even more efficiently. Okay? So that's the function of your eye. Your eye doesn't see anything. It just bends light in order to the receptors, or rods and cones, right, in the retina or the retinal layer, in the posterior layer of the eye. Now here's your lacrimal gland. It makes tears. Tears are not just water, and it's not just salt as well. You can taste it, of course, if you ever tasted your tears after or during a nice good cry, which you know I'm a fan of. And you can see here how the tears wash downwards. It washes into the lacrimal sac and then nasolacrimal duct, so that's why your nose gets runny if you have a prolonged crying session. Your eye moves around, cranial nerve 3, 4, and 6. Cranial nerve 4 covers the the superior oblique, and I believe 6 is the lateral rectus, and everything else is 4 or 3. Can't remember. Don't quote me on it. But what's the superior rectus, inferior rectus, medial rectus, lateral rectus, superior oblique, inferior oblique? Those are the 6 straight muscles, or recti, that are in your eye that move your eye up, down, left, right, and so on and so forth. And you can see here. So if my superior rectus contracts, that means it's going to draw my gaze or my eyes upward. Inferior rectus, downward. Medial rectus, if you're looking at my right eye, because the medial rectus will bring my right eye towards my nose. And if it's my right eye, it's going to the lateral rectus is going to make my right eye look towards the right. Superior oblique, up and to the right for my right eye. Inferior oblique, down and to the right for my right eye. And vice versa for your left eye. Look up online, there's nice little diagrams, and also to confirm the cranial nerve innervation. I can't remember anymore. Was it? I'll probably remember it by class. I'll look it up. It is late. Eye, you have your outer fibrous layer, remember the cornea, middle vascular layer, but of course the inner most important layer, or tunic or jacket, is the nervous layer, and that has if you can see here, that has this layer here that's yellow, the most inner layer, that has the retina, that has your rods and cones and connected to the optic nerve. If you see here, all the wires here connected to the optic nerve, but you're going to have a blind spot where there is no, it's called the optic disc, right? And you're going to have a spot here called your fovea centralis, which will have the most number of receptors. And this is where all of those light rays try to focus on. And when it doesn't focus on that area because of, whatever, your lens or whatever, or maybe your eye isn't shaped round, it's shaped more like an egg, and those are people like myself who have an astigmatism, right? Then you won't be able to see clearly, and then you have to have eyeglasses, which will refract light even further, so we can try to get everything, towards, where was I? Towards the back part of your eye. Ciliary body, we talked about that, talked about lens, right? Accommodation. That's what the lens does. When it gets pulled on by your ciliary body and ciliary muscles, right? It again refracts the light. Just like the analogy I had, the story I had when I told you when I was a kid, I used to burn ants with a magnifying glass. Anterior portion of the eye, the anterior chamber, is full of aqueous humor. Remember, the word humor doesn't mean ha ha funny in Latin. It means fluid or liquid. We also talked about, let's keep on going, the iris, right? Controls the amount of eye, right? And it's the colored portion. It has melanin. Remember, depending on what region of the world your genetics is from. Again, to the melanin in the amount in the iris is to deflect any excess UV radiation, because you know when you're outside, you're looking at light, but also UV radiation is also could get in as well. So the iris is the color part of your eye and has melanin in it, which determines the eye color, and the amount of melanin dictates the amount of UV protection your eye has. The iris also, the pupil can also dilate and constrict, and remember its relationship with the autonomic nervous system. Sympathetic nervous system, your pupils will dilate, and your parasympathetic nervous system, your pupils will constrict. Fovea centralis, again, sharpest vision, has the most rods and cones, or receptors, or photoreceptors. But the optic disc has no photoreceptors, okay? Because that's where all the wires from all the receptors have to go meet the optic nerve. And inside, we mentioned a little bit of that, but here is a little bit more important. You could see how lens and how your glasses will then what? Converge light or disperse light, depending on what kind of lens you need. But remember, the focus is to get everything towards the retina and most of it on the fovea centralis. We talked about this, how it's not really an image you see, it is light rays. Rods and cones. Rods are for night vision, right? And that's why and cones are for color and for day vision. Cones, you see colors. At night, you really don't see colors. You see like 20 million shades of gray. Here's a visual of what rods and cones look like. Don't need to know what the visual pigments are. You do need to know what stereoscopic vision. You need to see with both eyes, right? When you open up both eyes, it gives you depth perception, height perception, and remember, what one eye picks up, the other one can't. So they both move together like a stereo. Stereo is what? 2 channels, left and right. So that's what helps your brain interpret 3-dimensional images. You need both eyes open. And you could also see here, like, in order to see a 3D, you got to see it from 2 perspectives. And then it is not the eye that sees, it's the occipital lobe that then interprets the light rays that are coming in from both eyes. Don't really need to know the pathways, and that's about it. So thank you very much for putting up with me yet once again, and I will see you guys in class. Good luck on your exams.